So here's a good start to today's lesson. How many terms will it take for the geometric sequence defined by a sub n is 2 times 3 to the n minus 1 to have a sum of 59,048? Not for it to be 59,048, for it to have a sum of. So I'm going to take all these sequences, or all these terms, and I'm going to add them together. Well, I want you to think about how hard this would be to do recursively. But like if I found the first term, 2 times 3 to the 0 is 2. Second term should be 6, and it is. Third term should be 18, because we're tripling. I want to know, where do I stop? That's what I want to know. Where do I stop adding? So you could do this recursively by finding the terms and adding them, and it would take you a while. Although, to be honest with you, it might be quicker than what I'm about to do because there's the math, and we don't like the math. But I know that the sum of n things, if it's geometric, that's the key word, is the first term times 1 minus, don't forget the parentheses, r to the n over 1 minus r. That's what I know. All right, so I'm going to plug into it. The first term, this is, by the way, this dude is in, or over here, it's in form. The ratio is a 3. I don't know n. And I know that the sum is 59,048. I could do a y1, y2 here. I could. Or I could be a man and do logarithms. And I'm going to choose to be a man. I know that that's a negative 2. 2's cancel. So 59,048 is negative, because 2 over negative 2 is negative 1. 1 minus 3 to the n. Now, let's just distribute that negative n. 59,048 equals negative 1 plus 3 to the n. Add 1. 59,049 is 3 to the n. Log is bay. Remember, log is bay? Base, exponent, argument. A log base 3 with an argument of 59,049 is n. Push buttons in a calculator, change a base. And let's hope that I didn't make a mistake when I wrote this problem. If so, I'll pause and fix it and start the video all over. Anyways, change your base. Natural log of 59,049 divided by natural log of 3, which not enough of you understand. And that's on you, not me. It takes two people to learn, one to teach and the other one to learn. And it's just me teaching. 10 terms. Wasn't too bad. Logarithms. Love them. All right. This is supposed to be a U-try, but these are notes for kids that were supposed to be in a flipped classroom, which you guys didn't want to do. Write an explicit and recursive rule for this sequence, 1641. All right. So the ratio here is 1/4, because 16 over 4 is 1 over 4, and vice versa, 4 over 16. I wrote that backwards. 4 over 16, forgive me, I am tired, is 1 over 4. And 1 over 4 is also 1 over 4. So we have a common ratio of a quarter. This is your first term. Let's just start with the explicit rule. The nth term is the first term times the ratio to the n minus 1. So the nth term is a 16 times a quarter to the n minus 1. Or, for spits and giggles, let's say this is a fourth to the n over a fourth. Clear the fraction. The dividing by a fourth is like multiplying by 4. 64 times a fourth to the n. They're both valid rules. Recursively, you got your piecewise function. We are the first term of 16 if n is 1. And then we are the previous term times the ratio of a quarter if n is bigger than 1. And I don't need the second bracket on the recursive rules. Cool. Find the first 20 terms of the sequence and convert it to a fraction, please. Because your calculator can usually do that. Can't always do that. So we're going to find the sum of 20 things. It would be the first term of 16 times 1 minus the ratio of a quarter raised to the 20th power. So then pretty over 1 minus a quarter. And let's see if our TI-84s can do this or not. If not, we'll have to do it by hand. All right, so we got a 16, we got a set of parentheses, we go to math, we go to num, we go to n over d. Here we have 1 minus parentheses 1 over 4 rooftops to the 20th power. And if you don't know what 1 minus a quarter is, like you don't know it's 0.75, you know, your calculator won't judge you. You just type in 1 minus a quarter. 21.33333 forever. And when I say convert to a fraction, I don't mean 21 and a third. I mean the mixed fraction, which is going to be 64 thirds. Ta-da! All right. Why have I got this in here? Our U try from yesterday was interesting. Oh, because it was decreasing. And this may or may not be the same one. Yeah, because these notes are a little bit off. But anyways, our U try was interesting. Let's look at the graph of the explicit rule and see what's happening. Because I'm about to teach you about converging and diverging series. And if you're in class, you probably won't play along. If you're at home, you're homebound, you're probably not going to play around. I keep throwing the same thing out at y'all. And the issue is we don't try. That is 100% the issue. Like, I can't fix not trying. Like, you don't like the subject, I get it. You don't care, I get it. You got to try. Anywho, we do a Zoom 6. This will be an exponential decay because this is less than 1. And I may not see him. There it is. Now look at that graph. Let's go look into the future. Let's go out about 1,000 units. That thing flatlined, didn't it? What's happening is, as x approached infinity, y approaches 0. This is called convergence. So what is happening is the y value, which would be the nth term, converges or gets close to 0 and 0. It's also known as a horizontal asymptote. You know, things like that. Sum of an infinite series. So it turns out that you can actually add an infinite number of things together if, and that's the big thing, if. So the sum of an infinite series is simply the first term over 1 minus r. If the absolute value of the ratio is less than 1. Because if the absolute value of the ratio is less than 1, the sequence approaches 0. Kind of cool, huh? I'm going to pause real quick and see if I can explain this formula. It's been so long since I've done it. But let me do a little math behind the scenes here. So let me try and explain where this thing comes from. Here is your default summation formula for a geometric sequence. The sum of infinity is the first term times 1 minus that ratio to the infinite power over 1 minus r. Now, if you take a fraction like a tenth, which is less than 1, and you raise it to the 10th power, what you'll discover is it's going to get pretty small. Take a tenth, raise it to the 10th power, and it's already really small. There's 9 zeros in front of that thing. If you take it and raise it to the 20th power, which is, by the way, nowhere near infinity, you can see that it keeps getting smaller and smaller and smaller. What happens is, at infinity, this is basically 0. So we end up with the sum of infinity is the first term times 1 over 1 minus r, and then we just distribute the a sub 1, and we get that beautiful little formula up there. There's some limits and stuff in there. It's not a true math definition. It's a good enough definition for Algebra 2. But anyways, I can find the sum of an infinite series if the absolute value is less than r is less than 1. Now, there's more to this. If the absolute value of r is less than 1, this means that the sequence, or the series, but the sequence converges on 0. If the absolute value of the ratio is bigger than 1, the sequence diverges. And that means there is no infinite sum. So it has to be decaying to find an infinite sum. Decide if the series shown converges to infinity or not. If so, find the sum as n approaches infinity. This guy looks like mx plus b. This is arithmetic. The converges at infinity formula is for geometric. Here our ratio is 3, and the absolute value of 3 is definitely bigger than 1. The series diverges. There is no infinite sum. All right, here my ratio is a third. Cool. That's awesome. So I can find the sum. We converge. Now, in order to find the sum, I have to think about needing the first term. And this is something that a lot of kids will miss because a lot of kids are just too lazy. What they'll do is they'll say the first term is 4. It's not. I need a sub 1. I find a sub 1 by legit plugging in a 1. I can tell you right now, a lot of kids will tell me the first term's a 4. That's what you'll do because you're just too lazy. And then I get 4 times a third, which is 4/3. Now I'm going to feed my little formula here. The sum of infinity is 4/3. This is your ratio. The guy with the exponent is always the ratio over 1 minus a third. I'm going to do a little magic here. I'm going to do some math by hand. 1 minus a third, believe it or not, is 2/3. If you don't understand that, sorry. The 3's are in the same position. They cancel. It gives me 4 over 2, which is 2. I just thought it was kind of interesting that I could actually find the sum of an infinite number of things, but there is a big distractor. It has to be decaying, not growing. If it's growing, we can't do it. All right, this guy is 100% in the correct form. This is a sub 1 times r to the n minus 1. So I know that the absolute value of r is definitely less than 1 because it's a 6th. So I converge. No problem there. I know the first term is 3. I know a formula. The sum of infinity is the first term sitting over 1 minus the ratio. Again, I'm going to do a little more of that magic here for you. 1 minus a 6th is 5/6. To divide by a fraction, we multiply it by its reciprocal. 3 times 6 is 18, 18/5 all day long. Here we have sigma, which means find sum of, which means automatically by putting down sigma, half of you missed the question. That's just how it is. Cool, I got a sigma with a half in it. Your ratio is 2, kids. Series diverges. There is no infinite sum. Another sigma. Here the ratio is a half, but this is not the first term. If it was 1/2 to the n minus 1, it would be, but it ain't, so you can't do it. All right? To find the first term, we're going to feed this thing a 1. It's 3 times a half to the first, which is just 3/2. And again, the sum of infinity is the first term of 3/2, sitting pretty over 1 minus the ratio, which happens to be a half. This is 3/2 over a half. The 2's cancel. We're left with 3. We're going to do another one of these, and then we're going to do a summation problem. Geometric sequence has a first term of 3 and a common ratio of 2. How many terms does it take to reach a sum of 3069? So this is not an infinite one. This is a finite one. So back to that formula. First term times 1 minus that ratio to the n over 1 minus r. Now let's see what's known. I have a first term of 3. I have a ratio of 2. And I have a sum of 3069. So this is going to be done a lot like the last one was, okay? 1 minus 2 is negative 1. 3 divided by negative 1 is negative 3. Of course, you guys will create your own little rules here. I'm just going to divide it. Last time I did this, I did the distributive property. Here it's easier to divide by negative 3. And we'll get 1023 equals 1 minus 2 to the n. Sorry, negative 1023. I forgot to divide out the negativity. Now I'm going to take away 1. It's negative 1024 equals negative 2 to the n. I'm going to divide out the negativity again. 1024 equals 2 to the n. And it would be cool if you knew what this was by hand. It would be. I'm just going to do log is base, exponent, argument. A log of base 2 with an argument of 1024 is n. Which, by the way, says what power of 2 creates 1024? And if I don't know that, I can just do change of base, natural log of 1024 over the natural log of 2. And it would be cool if you knew off the top of your head what power 2 creates 1024, but, you know, I get it. 10. Just like the first one. 10. All right, express the series 3 plus 12 plus ... all the way to 3072 using sigma notation. N equals 1. Don't know the top. Okay. Is it geometric or arithmetic? This is definitely geometric because 12 over 3 is 4. So the ratio is 4. The nth term is the first term times the ratio to the n minus 1. So I know that the first term is 3, the ratio is 4, n minus 1. That goes here. All I got to do now is figure out where I stop. What's the top number going to be? Okay, plug in. 3072 must be equal to 3 times 4 to the n minus 1. And then I do math. I just do math. 3072 is divisible by 3. It's 1024. 1024 equals 4 to the n minus 1. And then I do logarithms. Base, exponent, argument. A log of base 4 with an argument of 1024 is n minus 1. Maybe go push buttons on that bad boy right there. That's a natural log of 1024 divided by the natural log of 4, and the answer had best be 5, or something's wrong with me today, and it is. 5 equals n minus 1, so n is 6. Sigma. This is probably why kids would say, what is sigma? Because that was probably some kid who barely understood math sitting in a math class and said, what the sigma? It ain't that bad unless you're that kid. You're given 2 terms of a geometric sequence. Ace of 5 is 10 and ace of 12 is 564. So find the first term, the common ratio, and write both the recursive and explicit rules for the sequence. This is a tough little problem. It really is. It is a tough little problem. You can sit there and be recursive and think about what you have to multiply and divide by, or you can use algebra. But it's geometric, so I know I get to plug into this rule right here. I am 10 on the 5th term, and 5 minus 1 is 4. I am 5/64 on the 12th term, and 12 minus 1 is 11. Now, I was taught in 7th grade, just like you were, how to divide something out. So the first term can be thought of as 10 over r to the fourth. And I was also taught at the same age you were about substitution. I just chose to actually learn the content because it bothered me not knowing how to do things. And it always bothers me not knowing how to do things. Let's clean this up. You got that r to the fourth over r to the 11th. That's r to the 7th. 5/64 equals 10 r. My r's in the wrong spot. R to the 7th. Do a little division. We're dividing 5/64 by 10. That would be 5/640, which will reduce. I'm just too tired right now to do it. But, you take your 5 over 64, divide it by 10, back as a frac, 1/128th. The opposite of the 7th power is the 7th root. To do a 7th root in a TI-84, you raise it to the 1/7. There you go. The ratio is a half. Now that I have the ratio, I can figure out the first term. A to the first equals 10 over 1/2 to the fourth. And half to the fourth is a 16th, right? Yeah. To divide by a fraction, we multiply by the reciprocal. The first term is 160. My explicit rule is the first term of 160 times the ratio of a half raised to the n minus 1. My recursive rule is 160 if n is bigger than 1, equal to 1, or the previous term times a half if n is bigger than 1. And there you go. There is your Geometric Sequences Day 2 notes. I'd love to say I hope you enjoyed, but you and I both know that ain't true.